Mom, I want to come home. Okay, heat of combustion. So this is pretty straightforward. It's just a special class of reactions. You're combining one molecule or one mole of some substance plus oxygen to get the various oxides you would get out of that substance. We're usually talking about hydrocarbons, so that means we're usually making carbon dioxide and water. And it's always normalized, so we're making 1 mole of the thing that's being burned. So we're going to get more fractions for these. And you'll get a table that looks like this. So 1 mole of cyclohexane plus 9 oxygen molecules makes 6 carbon dioxide and 6 water. 1 mole of cycloheptane plus 21 halves oxygen makes 7 CO2 and 7 H2O, and so on. And then we have an enthalpy of reaction for this, which is called the enthalpy of combustion. Okay. It's relatively straightforward. So I'm only going to work through one example because I don't want to do more. So let's just do the cyclohexane, okay? C6H12. Okay, so we're doing 1 gram of the cyclohexane. Okay? So how much heat would you produce from that? So our enthalpy of reaction is negative 3920 kilojoules per mole. All right, so 1 gram of our cyclohexane, how many moles of that do we get? So grams per mole. It's 84.161 grams per mole. We have 0.01188 moles. Let's go ahead and call it 4 sig figs. All right. Okay, so that's pretty simple. And then our enthalpy of reaction, so it's just negative 3920 kilojoules per mole times 0.01188 moles. So negative 46.58 kilojoules of heat. So these don't really add a heck of a lot of complication. I mean, they're a very standard enthalpy problem. I mean, all that's really happening is that we have set up a slightly different variation on the formula, such that we want 1 mole of the thing being burned, and everything else will bend around that. Okay. So I think you, at this point, if you can handle enthalpy of reaction problems at all, will be able, with no trouble, to handle a combustion reaction problem. It's just a class of reactions that they've decided to treat separately. Okay, like I said, this one went relatively quickly. We are done with the heat of stuff problems for the night. Tomorrow we'll return with spontaneity, entropy, and Gibbs free energy. I will see you later.